Hey everybody, welcome to Math 30-2. We are in for a super quick lesson today for Lesson 8 on factoring. So let's get started. So today we are going to look at factoring, but we are going to be turning that up just a notch. And we want to start out by factoring more complex difference of squares. But before you can factor the difference of squares, we want to make sure we understand what the difference of squares is. Well, the difference of squares is an expression where there are two terms. The terms are separated by the subtraction operation. And they can be expressed as a squared or b squared. So let's go back. The difference of squares would be something like that. Now, in the past, our a could be a number or a coefficient with variable. Same with b. And that's what we've dealt with mostly in the past. And we realized once we had that, we can quickly factor it using this little rule. So let's look, and I want you to pause the video and try to see if you could figure out the factors of each of these expressions. When you're finished, come back and see how you did. Okay, let's see how you did. Well, the first one, easy peasy. We're going to say our A equals S. No problem. We're going to see our B. Well, we can rewrite this one as S squared plus, not plus, let's get rid of that. Losing my mind. Minus 3 squared. So the B equals 3. Therefore, we can factor this expression by saying S minus 3 times S plus 3. That wasn't too bad. Well, let's move on to the next one here, where we have 16x squared minus 25. Well, A in this case is going to be 4x. The reason we're going to do that is because that 16 is 4 squared, so we have 4 squared x squared. And let's go, we'll just write this down already. That's 25 is 5 squared. And this can be rewritten as 4x squared. So we're using a little bit of exponent rules here to get everything inside the bracket like that. And our b equals 5. So this factored would be 4x minus 5, 4x plus 5. Oops. All kinds of mistakes happening here today, folks. Okay, let's do it again. Let's rewrite it first. We're going to say 2 squared r squared minus 3 squared s squared. Using our exponent laws, 2r squared is the same as 2 squared r squared. And same thing with this side. And this means that factoring this out, we have 2r minus 3s times 2r plus 3s. And at some point along your mathematical journey, you would have seen something probably as complex as that. But I want you to look at what Fatima did right here. She has something that also looks like the difference of squared, but it's much more complex. we have 4 times x plus 2 squared minus y minus 4 squared. Well, look what she's did. She's taken out the x plus 2 and substituted r equals x plus 2 and y minus 4. She's taken out the s to equal y minus 4. And now she has this much simpler equation, 4r squared minus 9s squared. She's gone ahead and used her ordinary difference of squares, and this was just like the one we saw up there, where we have 2r minus 3s times 2r plus 3s. And then when she gets it to this point, she substitutes everything back in. Notice here we got the x plus 2, the y minus 4, and then she has everything inside the brackets, which she simplifies down to these two factors in terms of x and y. So what does this tell you about the factoring of the difference of squares? For factors where we have a squared times f of x, some function squared, and we are minusing b squared times some other function g of x, say, squared, we can substitute some value r to equals f of x and s to equal g of x to simplify the expression. And that's going to make it easier to work with, as you've seen in this example. Okay, so let's look at factoring a difference of squares. And we're going to do this not for the basic type that we've been used to looking at, but for the type where rather than just an x or a y in here, we have a little function f of x or g of x. So let's look at a good strategy. We're going to use that substitution strategy where r is going to equal f of x and s is going to equal g of x, and we're going to replace those functions with r and s. Well, in this example right here, the x plus 1 becomes r, and the y minus 1 becomes s squared. The next step is we're going to rewrite the coefficients a and b as squared numbers. If this is not possible, it's not the difference of squares. So we got to look at these numbers here, and those are going to be perfect square numbers. If they're not, we can't factor it. So 9 is 3 squared, and 36 is 6 squared. The next step is we are going to bring the base of the squared coefficient inside the bracket with the variable and place the square bracket on the outside. And this is an exponent rule. 3r squared minus 6x squared. Now we're going to rewrite as a minus b, a plus b. Because in this case, our a is 3x and our b is 6s. So it's 3r minus 6s and 3x plus 6s. 6s for success. Now let's substitute the r and the s back in. So wherever there's an r, we're going to put f of x, which is x plus 1. And wherever there's an s, we're going to put y minus 1 back in. So we get this expression right here. Now, lots of bracketing, so you want to take care. The next thing we want to do is simplify, and we're going to do that by distributing all of these things through. So let's get out a little pen here. So the 3 is going to be multiplied by this and this. The negative 6 by this and this. And remember, a negative times a negative makes a positive. So we're doing a bunch of distributing here. And that's going to give us 3x plus 3, negative 6y plus 6, and that's in one bracket. The next bracket, or the next factor, is 3x plus 3 plus 6y minus 6. We're going to gather like terms, so the 3 plus the 6 makes the 9, and the 3 minus the 6 makes the negative 3. The next thing we're going to do is take out some greatest common factors of each of these trinomials. Now, notice it's a trinomial, but it's not a quadratic. So we're going to take out a 3 from each term. So in other words, divide each term by 3, and that's what's left. So we get 3 times x minus 2y plus 3. And then here we also have another 3 that can be factored out and get x plus y minus 1. We have a 3 here and a 3 here. They multiply to 9, and we're left with these two factors. Let's move on. Okay, let's look at this one we're going to factor some of these binomials. So we know we're going to be looking at the difference of squares. I'm going to rewrite this to start. I'm going to leave the first term right now, but I'm going to actually do what we did where we're going to make this 5 squared times 3y squared like that. And I'm actually going to rewrite 2x squared minus 5 times 3y inside the brackets and then put that square. This is just going to simplify things for us when we substitute r and s. So this means inside the brackets here, I get 15y. Well, that means if I substitute r equals 2x and s equals 15y, I get r squared minus s squared. And that's going to give me r minus s times r plus s factors. Now we're going to substitute back in the r and the s. And we're going to do it over here as well. And then we're done. Nice work. Let's do the next one. In the next one now, we're actually going to make the substitution first. I'm going to let r equals x minus 3 and s equal y minus 1. So for the first one, I get 16 r squared minus 49 s squared. Well, now I have this r value, or the 16 value here, and we know that this needs to be written as squared values. Same with the 49. Again, if you can't square it, then it's not a difference of squares. And rewriting this, we get 4r squared minus 7s squared. Well, in this case, this is the same as saying A equals 4r and B equals 7s. So that's the same as saying 4r minus 7s times 4r plus 7s. Now that we have that, we're going to take our original substitutions and put everything back. So that's going to be 4 times x minus 3 minus 7 times y minus 1. Careful with the brackets. 4 times x minus 3 plus 7 times s minus y minus 1 for the s. We're going to distribute the coefficients. A lot of distributing. So we get 4x minus 12. That's just a nothing there. Minus 7y plus 7. Minus 7 times a minus 1 is plus. That's our first factor. Here we have 4x minus 12 plus 7y minus 7. That's our second factor. Let's simplify. Well, we have 4x minus 7y and minus 12 plus 7, which is negative 5. The second factor is 4x plus 7y, and minus 12 minus 7 is minus 19. And this is the factored form of b. Okay, now we're going to use the same type of substitution method to factor trinomials that are of the form a equals f of x squared plus b f of x plus c, where a is greater can equal 0. And this comes from this type of trinomial right here, which can sometimes be factored dx plus e times f of x plus g. And we did some examples of this in a few lessons before when we were factoring using the x method. Well, even though a trinomial has an f of x here rather than the variable x, we can still use this substitution method to factor. So let's look at an example where we have 4 times x plus 1 squared plus 4 times x plus 1 minus 3. Notice that that looks very similar to 4x squared plus 4x minus 3, which is a trinomial that we could factor. So in order to make it look like a trinomial we can factor, we're going to identify the f of x and let a equals f of x. So in this case, I'm going to say my f of x equals 1, and therefore a equals x plus 1, and wherever there's an x plus 1, I'm going to put the a. So now I have 4a squared plus 4a minus 3. Now this is something that we know how to factor. Now in the notes here, I've done what's called the grouping method, and some of you may have seen this before. It's actually built from the x method. It's the same concept, it just looks a little different. What we do here is we take the a value and the c value and multiply them together to get negative 12. Just like the x method, I'm looking for two numbers that multiply to negative 12, but add to positive 4. In this case, I'm going to say it's 6 and 2. So I'm going to break up that middle term, negative 2. I'm going to break up this middle term 4a into two terms. I'm going to break it up into 6a and 2a. Now that I have that done, I'm going to bracket off each term. Now I notice I made a mistake in my brackets. Let me fix that. So I've bracketed off the first term, 4a squared plus 6a. Now I want to bracket off the second term, but I got that subtraction sign there. So what I'm going to do whenever I have a subtraction sign in the middle, I'm actually going to go ahead, put brackets here and change the middle sign, because really what I want is this is like a negative 1. So if I multiplied that negative 1 back through, I need to end up with minus 2a minus 3a. And that's the only way we can do it. So we are switching the sign of the 3 and pulling out a negative. If this is confusing you, make sure you definitely get in contact with your teacher if you're interested in learning this grouping method, or it also can be considered called decomposition. So now what I want to do, I have these two terms. I'm going to factor out any common factors. Well, in the first one, I have 4a squared plus 6a. I'm going to take out a 2a, and that's going to leave me with 2a plus 3. Now over here with this 2a plus 3 here, notice I can't factor anything out. I'm just going to throw a 1 in front of there. And the reason I'm going to do that is notice I'm going to have a factor of 2a plus 3 in both. So that means I have 2a plus 3 as one of the factors, which means the leftovers are 2a minus 1. So this is the factored form of the original expression up here. Now, if you don't like this and you want to go back to the X method or any other method that you know, definitely go ahead and do it. I don't want to confuse. Stick with what you know. So now we're going to do our substitution back. We're going to take our a equals x plus 1, and wherever there's an a, we're going to put the x plus 1 back, and then we're going to distribute the 2's and simplify. And when we do all of that, we have our two new factors. So let's go ahead and do a little bit of practice with the next two examples. So for this example right here, we have, let's say, a equals 3m. So I make my substitution. Like this. Now let's factor it. We can't take any common factors out because we have an odd number and some evens. So we can't get that factor out. And these are not multiples of 3. So we go ahead and we go 3 times a times c, which is 24. And we're going to put our b value down here. I'm going to put 3a here. And I'm going to find two numbers that multiply to 24, but add to negative 14. Now, negative 14 is quite a big number. That must mean I have to have a bigger multiple of 24. Now, a bigger multiple of 24 is 12, and that would have to be multiplied by 2. But this is negative 14, and 12 plus, remember this is plus, this is multiply, 12 plus 2 is positive 14. So the only way this is going to work if these two are both negative. So negative 12 times negative 2, positive 24, negative 12 plus negative 2, negative 14. The next thing we want to do is reduce any fractions. Well, the left-hand side has a negative 12 and a 3 on top. I'm running out of room. Let's put it right here. It's going to be negative 12 divided by 3 is 4, so it's negative 4 over 1a right here. Now, if you want to throw the a in afterwards, that's okay, but we got to make sure we keep that one. So we're going to bottoms up everything. So now this gets reduced to a minus 4 times 3a minus 2. Now we have our nicely factored trinomial. We're going to plug the a back in, and we're going to get 3m minus 4 times 3 times 3m minus 2, and that gives 3m minus 4 times 9m minus 2, And none of these terms here have common factors that can be taken out, so we are good to go. Let's look at the next one. In the next one, we can easily see that our a is going to be x minus 2. So our new trinomial to factor is 2a squared minus 3a minus 27. Well, we don't have any greatest common factors to take out, so what we're going to do is we are going to add some equal signs. And we are going to multiply 2 times negative 27, which that is going to give us a negative 54. In the middle, at the bottom, we got a negative 3. So remember, this is multiply, this is add. We're going to put 2a here and 2a here. We need two numbers that multiply to negative 54 but add to negative 3. So these two numbers need to be close to each other. Not like that negative 12 and negative 6 that were so far apart. These have to be close to get a negative 3. And in particular, we need one number bigger than the other, and one needs to be positive, and one needs to be negative, because this is a negative 54. And we can only get a negative if one is positive and one is negative. Well, I know that 6 times 9 is 54, which means if I want this to work, the 9 needs to be negative, because negative 9 plus 6 is negative 3, and negative 9 times 6 is negative 54. So let's start by reducing some of these things. This is going to be 3 over 1a, and this one can't be reduced, so it's going to be left at 2a minus 9. So 2a minus 9 times 1a plus 3. Now we don't have to put the 1 there if you don't want to. And now we're going to substitute things back. So I'm going to say 2 times x minus 2 minus 9 times x minus 2 plus 3. You could put this in brackets if you wanted to. Distribute. And negative 2 plus 3 is positive 1. And this leaves us with 2x minus 13. And there we go. Now for the last one, why don't you take a moment, try to see how you do, and come back and see if you got it right. Now, how did you do? Well, if you used the x method, you would have come up with 2a minus 3 and 2a minus 3. So look at that. We got a perfect square trinomial going on here. And then we have 2a minus 3 squared. Substitute the x plus 3 in. Distribute the 2 to get 2x plus 6. Simplify the 6 and the negative 3. Then we get 2x plus 3 squared. Well, that's the end of this lesson. Head on over to the practice work. If you find anything that is giving you trouble, make sure you get in touch with your teacher right away. I hope you have a great rest of your day. Take care.